Hello and welcome to Mr. Davis's classroom. This is Mr. Davis, and today we're going into Algebra 1, Lesson 8-7, Part 1, which is factoring special cases. Today we're just looking at the first part here, which is to factor perfect square trinomials. Okay. So hit pause, start this warm up. When you're ready, we'll move forward. So the first key concept that we have here is that there are things that are perfect squares. And what we mean by perfect squares in the most simple term is when we take a number and square it, we get out a nice number. So these are all perfect squares. Okay. Now in polynomials, they're written like this, or we have our binomial in parentheses squared. So a couple examples are, down here we have x plus 4 squared, or 2n minus 3 squared. So that's how we write them in polynomial form. In polynomial form, they will always look a similar way. For example, if we look at this one right here, if this last term is a perfect square, right, it's b squared. 16 is 4 squared. Then right here, I know that that's just 2 times 4 times the first term, x. Okay, and we should get pretty good at this as the day goes on. So let's start here. Okay, what is the factored form of this perfect square? Well, first thing I notice is that the first term is a perfect square, and the last term is a perfect square. It's 6 squared. Then in my head, I just need to think, is this middle term equal to negative 2 times x times 6, or if I combine those two terms, negative 12x. If I look, those are the same, which then tells me that this is a perfect trinomial, right? So that's perfect. So I know it's going to be a parentheses squared. I know that's going to be my first square, which was x in front. My second term is going to be 6. Ooh, that's an ugly 6. Let me retry. My second term is going to be 6. And since it's a minus sign there, it's a minus sign here. And that's my answer. Okay? Now, it is nice if you can see this. Right? It is nice if you can see that negative 12x is double the square of the last term. Okay? It is nice. It's a shortcut. It's not necessary. Okay? I know there's some of you out there right now that are saying, like, I'm barely getting factoring. Okay? Well, let's just factor this one normally. Okay? Well, I don't need AC factoring because if it's just x squared up there. So when I do my x factor, I need two numbers that multiply to get 36, add to get negative 12. And as you do this, you should think negative 6, negative 6. Now, those of you that are going to do the x factoring through this lesson, at this point, right here, you should be thinking, I have a perfect square. I have a perfect square. Okay? And as soon as you see that, you should be able to write x minus 6 squared. Okay, you should be able to go straight there. But let's write that step that we skipped over, which is x minus 6, x minus 6. Then we see that those two are the same value, so we can rewrite them as a perfect square. Okay. Now, I'm not going to require that everybody is able to see perfect squares and write them as such, but I will require that you can use regular factoring after it's factored. Realize that it's the same binomial and rewrite it as a squared term. Okay. Oops, wrong way. Here's 2 for you to try. Please try these before moving forward. Okay, so computers use digital images. They're tiny squares called pixels. And say here we have a pixel that the area they say is 4x squared plus 20x plus 25. It says, what's the length of one side of the pixel? Well, one thing that we should notice is that each pixel is a square. And if we think the area of a square is equal to length times width, but length and width are the same number. So a lot of times we can think of area of a square as just being side length squared, okay? I know my S's look like 5s, but that's an S, all right? So side length squared. So we should have a perfect square here. Well, first thing I want to do is I want to look, can I rewrite this as a square, right? I know I have x squared, but I got this number in front now. I need to make sure that whole thing is squared. So 4 is also a perfect square for 2, so we're going to write that perfect square in front. The b value also should be a perfect square, which we can see is 5 squared. In the middle here, I need to make sure that it's equal to all the parts, okay? Well, first check is x and x, okay, good. Then in the middle here is supposed to be 2 times my forgot my plus sign, my first and my last term. So that's going to be 2 times, let's see, I have a 2 here, I have a 5 there, 2 times 2 times 5, which is 20, okay, which is 20. So we know we have a perfect square here, which is going to be 2x, right, that's my a term. My second term is 5, plus sign here, plus sign here. Last piece is the squared, and that's my answer. All right, so the side length is 2x plus 5 for one pixel. Now, you could have solved this one with factoring as well, and if you did, great job. Hopefully you ended up with the same answer with us. Okay, moving on. Here's another one where we have a square patio, so similar to the pixel example, only difference is that square patio is quite a bit larger than a pixel. Here's your homework on page 514. Thanks for stopping by, and hope you enjoyed Algebra 1.